So, like I said, one of the practices or areas indeed that we pay particular attention to safety is work happening in confined spaces. The picture you can see on the screen gives us a quick understanding of what a confined space is. Some of us might have seen this kind of picture, this kind of space. It's a tunnel kind of, and sometimes we see it on the road when we are maybe driving. We see an iron cover there. Most of some places in town in Abuja have the electrical installation in a kind of in underground, and sometimes maintenance job has to happen in such places. When you walk in a
When you walk
place,
in a place,
when you walk in a
when you walk
place,
in a place,
all right, when you walk in a place like this, it's quite hazardous, quite hazardous. Some other examples that comes to mind is you having to do any work in a place like in a pipeline or inside a storage tank. You understand? Maybe some work, any form of work that takes you in such a space we call a confined space. A confined space is a space that is not designed for workers to work for a long time. It is only designed for a quick work and not for a continuous occupancy. What makes it a confined space is because the opening for both entry and exit is quite small. We use the word is limited. That's what makes it quite confined. And because the same opening you use for entering is the opening you use for exiting, the ventilation there is usually poor, so quite unfavorable. And like I said, it is not a place you put table and sit to work for a long time. So it's not designed for continuous worker occupancy at all. It is not designed for that. So the real question we want to be, okay, I think we still have some pictures that that gives us further understanding of what work a confined space is like. That's like a storage tank, whatever it is, whether it is water, whether it is any other form of materials or substance that is being stored there, gas, petroleum product, and so on. That's manhole. The one we saw earlier is also a manhole. That's a pipeline that we can see there. So, um, what makes a confined space hazardous is because of the atmosphere that is always hazardous. Because the space is just, it only have one space for both entry and exit. There's a likelihood that movement of natural gas or natural air may not be too effective. And once natural air is not effectively moving or ventilation is not effective, be sure that whenever any toxic gas enters there, it's likely going to settle or stay there for some time. And that really will create a kind of a hazardous atmosphere. So another reason why that space can be hazardous, the atmosphere inside that space can be hazardous, is that oxygen could be quite deficient, meaning there may be no enough oxygen level to to sustain someone to really work there safely. You understand? So when we say oxygen level is deficient, like I said in our last class, it means the oxygen level is somewhere around below 19 or 19.5. Below 19, 19.5, we say is quite deficient. You understand? So, and sometimes also there may be some flammable gases in the space they are trapped, and some toxic things in there that makes it quite unsafe for people to walk in. So those are the things that make up a confined space quite hazardous. one, oxygen could be deficient in the atmosphere within the space. The atmosphere inside that confined space could be quite vulnerable to fire outbreak. That's what we mean by vulnerable. And because of some bad gases that could have been trapped here, it could also be considered toxic. You understand? One of the things that makes it toxic, the atmosphere toxic, could be the work that is being done very close to the space. It may not even be inside the space. Some activities happening around where the space is can be the source of introducing some harmful element into that space, and it is trapped. So what's the safety procedure? Whether you are working in the confined space or whether you are supervising a group of people working in confined space, what's the safety procedure? First thing first, there must be a permit. Usually, work in confined space is considered HSA critical, and they need to be a permit before you start working in such space. Like we said in our previous class, the goal of permit is just PTW, is to ensure that every measure has been put in place to prevent accident from happening. So that's why we say you need permit. Beside permit, before you enter a confined space or have anybody you're supervising enter a confined space to work, we need to do the testing of the atmosphere inside the confined space. You understand? Like I rightly said earlier, oxygen could be deficient, so it's only by gas testing you can know the level of oxygen there. I said also toxic gases could have been trapped in there. It's only by testing the atmosphere that is when you'll be able to know whether there are some toxic gases. And of course, one of the most common toxic gases that easily get trapped into the confined space is what we call hydrogen sulfide. You understand? So safety measure number one before any entrance into a confined space is do a gas testing of the atmosphere inside there. And one of the biggest cautions we must take, like some people will tell you, I can perceive whether I can use my nose to perceive whether certain gases are available or not. Some gases are odorless. And if you decide to depend on just your senses to know whether the confined space is safe or not in terms of the atmosphere, it could really be misleading. Many gases cannot be seen. Many toxic gases does not even have smell. You understand? So it's totally not advisable to use your sensory organs to do just that. We have an equipment that guides people. That's the gas testing equipment. Like the image we have on the screen. You can see, let me use my pointer. The man is holding the electronic device with a sensor. So this pole kind of is a sensor. You can see that there's a cable connected to it. So there is a gas testing equipment that is by design to sense gases in the atmosphere. It can tell you what level of oxygen is available in a space. It can tell you other gases that are also there and their level. That is to give you an idea whether if it is oxygen, is the level adequate enough to support people to work there safely. If there are toxic gases there, it helps us to know these are the toxic gases in the space. So gas testing is very, very important. The image you see beside this man is depicting the inside of the confined space from the top down to the very bottom of it. So the arrow here is telling you that this is the top, and the arrow facing here is telling you is the bottom. And we demarcated it into three portions: one, two, three. What is the point? Anytime you are doing a gas testing inside a confined space, it it must be it must be done in the three positions of the confined space. You must take the sensor very close to the top, as in to the opening of the confined space, because gases that are lighter than air will always hover around the very top of the confined space. So you're to put your electrode very close up here so as to give you a reading of what gases could be hovering just around the entry of the confined space. I think we gave an example like methane. Gases like methane are lighter than air and they will always hover around the opening of the confined space. So the second point area you measure is the middle part of the confined space. There are some other gases that have the same weight with air that will always settle around the middle part of the confined space, like carbon monoxide is said to have the same and what you call it weight with air, and it's toxic. You understand? Then you also take your electrode very right at the close to the bottom of the confined space. That will help you to know those gases that are heavier than air that settles at the bottom of the confined space. And an example, like I said earlier, is hydrogen sulfide. So please, that's the technique. That is how we measure, how we take the reading of the gas status of a confined space atmosphere. If there's anything I have said this evening, I've said before you enter a confined space, please test the gas status of that confined space. I think the second thing I said in follow up is that in testing gas, please try to get the reading at the top of the confined space, get the reading of the gas at the middle of the confined space, and get the reading of the gas at the bottom, so that you can have the full picture of the gas status of that confined space. Now, once you know the gas status of the confined space, it enables you to now begin to know what to do. If there are toxic gases in the confined space, if oxygen level is not enough, then you will need to ventilate, what we call ventilation. You need to ventilate the confined space. The idea of ventilating if there are toxic gases is to dilute it, is to deconcentrate the toxic gas level in that space. The idea of ventilating if oxygen level is low is also to see whether you can boost the oxygen level of that confined space. Remember, ventilation is done with air. You understand? Ventilation shouldn't be done with oxygen. It must be done with air, because if you do ventilation with oxygen, maybe you brought in your oxygen cylinder to say, okay, because oxygen is not enough, let me just flush the space with oxygen. No, if you do that, you discover that that place will have surplus oxygen. You understand? And it will be oxygen rich. That is what we usually call it. And once a space is much in oxygen level, it becomes vulnerable to fire outbreak. The next topic we're going to be talking about is fire. You discover that one of the things we need to be in place for fire to occur is oxygen. So please, ventilation is done with air. So the air is intended to force, if there are toxic gases, it will help to force out a great volume of those toxic gases and probably bring it to a level that is a lap. Remember what I called a lap, as low as reasonably practicable. So another safety measure number 2 after testing and ventilating is to make sure that before working a confined space, it has to be isolated. Isolated means cordon it off. It must be movement in and around that place during when work is going on must be restricted, so as to protect also any other persons who are within the vicinity. Even if it takes that you use a caution tape, maybe to cordon off, to form a kind of a perimeter around where you are working, it is very, very important. When you ventilate, we expect you to repeat your gas testing. Remember, you were ventilating because maybe the toxic gases are quite high, or maybe the oxygen level is deficient. After your ventilation, repeat your gas testing. so that you can know the new status of the atmosphere. Repeat it. When you repeat your gas testing and you discover that that the toxic gases are still in there, but oxygen is enough. Mark my language. When you do your gas testing again after ventilating, and then you discover that oxygen level is okay, but there are still some toxic gases in the confined space. In such a situation, if you must enter the confined space, enter with respirator, what we call self-contained breathing apparatus. Self-contained breathing apparatus, and there are two of them. We had one we call air purifying breathing apparatus, or air purifying respirators, and air supplying. I think I showed us the, what do you call it, the air purifying and the air supplying sometimes last week. Just allow me, as in during our class last week. Let me see whether I can find it. What is this? Is this? Let me see whether I can find it and just. That's when we're talking about personal protective equipment. Let me just display it. Just a moment. Yes, I think I've seen it. Okay. Okay. This is what I'm talking about. I hope we can see it. So this is self-contained breathing apparatus. These are self-contained breathing apparatus, which is an example of PPE. Victoria Asobwa, kindly put off your mic so that I won't put you at the waiting room. So there are two kinds of self-contained breathing apparatus. We have the one that is air supplying, like this one we have here that this man is wearing, is air supplying. You can see that the air cylinder, the oxygen cylinder, some people will call it, is right there at the back of the man. You understand? And then, a lot of time we call it oxygen cylinder, but remember that what we have, human beings take oxygen in air. So what we have here is usually air and all that. So that is air. This air supplying can only be used in a confined space where oxygen level is adequate, but just that, where oxygen level is deficient, I mean to say. So when oxygen level is deficient in a confined space, that's when you will need air supplying. But when oxygen level is enough, is adequate, but okay, why, why, excuse me. Sorry, just a moment. My my what do you call it? My PowerPoint stopped working. So let me open the material again. Just a moment. This week. All right. All right. Let me go back to the slide where I was. I will still share it, please. Yes. Yeah. Share the slide. All right. So, like I was saying, when oxygen level is sufficient in the confined space, you don't use this kind of self-contained air supplying breathing apparatus. You use what we call air purifying. I want to re-emphasize and repeat what I have said. There are two type of breathing apparatus we use in confined spaces. One is called air supplying. Like the name goes, is to supply you air, oxygen to breathe. The other one is called air purifying. It is certainly to make sure that you are not breathing in the toxic element in the space where you are walking in. Now, I said the air supplying, like this one we are seeing this man wearing, is only used if the oxygen level in the space you are walking is adequate. Just that, I mean, if the oxygen level in the space where you are walking is inadequate, so you need air to be supplied to you to be breathing. Now, the air purifying, which is I'm going to, what is happening to you? Move. This is air purifying. It is not connected to any cylinder supplying, and you don't use it where there is deficiency in oxygen. The intention for this breathing apparatus is to purify the air that is going into your body, into your nose. So we only use it when there is enough oxygen where we are walking, just that there are other contaminants in the air where we are walking. So you need it to be purified before you use it. So we said in confined space, before you enter, make sure that you you have the adequate respirator if there is need for respirator. If there is no need for respirator, you definitely will know by the testings that you have done. Another safety procedure in confined space is never enter a confined space without a standby or a rescue team. These are two different responsibilities. A standby is somebody who is going to be stationed just at the very entrance of the confined space. The person must not enter. The person is just to be at the very entry point of the confined space to monitor whoever is walking inside the confined space. You want to make sure that the person is stable. You want to make sure that the person is sticking to the guideline of working in the confined space. You want to make sure the person does not stay beyond the time allowed to work in the space. There are some confined spaces that people die because they stayed more than the time they were supposed to work. If they had stick to the time they were supposed to remain there, they probably would not have been involved in the accident they got involved in. One of the works or responsibilities of the standby is to ensure that he asks you to evacuate when it is time you're supposed to evacuate. Victoria, your mic still came up. Please help us control your device. Thank you. Asoba. You understand? So one of the major responsibilities of the standby is to ensure that you you evacuate when you're supposed to evacuate. So if you're given 15 minutes to do your work in the confined space, once it is 15 minutes, the standby will ask you to come out. If you're playing familiarity because it's your colleague and you're like, my guy, calm down, Joe, let me quickly finish this instead of coming back again to this place. And it's beyond 15 minutes. He is expected to treat that case as an emergency. Even if you are talking with him, as long as it has gone beyond the time you're supposed to stay, the standby responsibility is to activate the emergency procedure, meaning he is to reach out to the rescue team, letting them know that it is time up for this so person to be out, but it's not out from here. He needs to be rescued. Remember, being a standby does not equate to being a rescuer. If you are not trained to rescue someone in a confined space, do not attempt. Statistics holds it that most deaths, most casualties that has been recorded in confined space has been people also who try to go rescue other people in the confined space. If you are not trained to go into a confined space to rescue anybody, do not attempt. One of the reasons is so that we can reduce the number of casualties. There is always a group of people trained to respond to such situation, and they have to be called on board in situations like that. In HSC, we recognize fire to be one of the most common hazards that every company should always have a plan and preparation for. Why we say it is one of the common is because what causes fire is basically three elements, and that is oxygen, that is heat, and that is fuel. So that three element that causes fire, we discover that two of them are always available anytime, any day in our workplaces. For fire to occur, these three must combine. So people define fire as a chemical combination of oxygen, heat, and fuel. So for fire to occur, these three must marry. They must come together. They must combine together, and fire will happen. So we use this illustration and we say fire triangle. And I said why fire hazard is one of the most common hazard in so many workplaces is because the two of these elements we are seeing that causes fire, two-thirds of it are always available. Number one, oxygen is always available in the atmosphere. That's what we breathe. That's what sustains us. So oxygen is always available. Number two, most of the things in our workplaces are fuel. Most of the things in our workplaces are fuel. I need to talk about the table. They are made up of wood, powerful fuel. I need to talk about probably the plastics things made up of plastic in the workplaces, powerful fuel. Is it the papers with which we work? Very, 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 very effective fuel. And the list goes on. If you check around your workplace, close to 80 to 90% of the materials around you in your work environment can burn. What is fuel? Anything that can burn is fuel. Anything that can burn. Maybe if you remove the wall of your office, that is, if the wall of your office is made up of mortar and sand, if it is made up of cement and sand, if you remove the wall of your office, I think practically every other thing in the office, in your workplace, is fuel. But for those of us whose wall is maybe a partition done with a material, the fuel increases in quantity. Fire is devastating. The only thing that we need for fire to happen, since fuel and oxygen is always available, is just the third element, heat. If you understand fire, if you understand that these are the things that causes fire, we will be able to take proactive measures to prevent the three of them from coming together, which is actually how we prevent fire. Just make sure that these three elements does not in any time come in combination, are not brought together in one place at a time. When it comes to issue of fire safety, everybody in the workplace must know how to deal with fire. Why? Because most fire begins small before it starts to rage, before it goes wide. And when fire begins, that one person that is right present there when fire started, if he knows what to do at that very point in time, that one person is a million times more valuable than 1 million firefighters who are still a kilometer away. I hope we understand that illustration. One man, one woman who knows what to do in event of fire and is right there when fire began. That one person is 1 million times far more valuable than 1 million firefighters who are a kilometer away. A kilometer away, anything can happen for the firefighters. The road could block. Their equipment, that is their vehicle, could break down. You understand? Anything could happen and they are not able to even come down to where the fire is. But if you have that man, that woman right there, and he knows what to do, that person can help the situation. That's the reason why it's very important. Everybody in the workplace should be aware what to do in event of fire. What do we call for? Again, like I said, this triangle paints the whole picture about what causes fire: fuel, oxygen, heat. What do we call fuel? Like I said, anything that burns. That is fuel. It can be solid, it can be liquid, it can be gas. We have so many solid fuel, like I said, in our office places. You understand? We have gas. Some of us, we use body spray. That's even a source of fire also. I'm not saying you should not use it, but of course with a great caution. Some fuel also come in form of liquid. Whatever form it comes, if it can burn, is a fuel. Oxygen, like I said, is everywhere around us. Nobody, if you're looking for oxygen where you are, then you're not supposed to be listening to me. It is readily available. It is not scarce. In natural state and also in some chemical compound, like in nitrate, like chlorate, you understand, like chromate, like peroxide. We will not go too scientific or too chemical and all that. So there may be some materials that are oxygen loaded. Those things also makes fire more vulnerable. You understand? Heat means any source of ignition, anywhere that ignition can arise from, and it can come from any source, many sources. It could be that your machine is not well lubricated, and because of the friction among the parts, it causes ignition and there is fire. Sometimes you see people deliberately set fire on something with an intention probably to damage something deliberately, or most time it's just to damage something deliberately. A lot of time I hear stories in news in Nigeria of a certain case that is being investigated, and before you know it, we hear that social office has been burnt. What happened? It is an office, the office associated with the investigation. Recording in progress. It is the office associated with the investigation, and then the next thing we hear is that fire has engulfed it. And some of us will say, they are trying, somebody has set fire there, so as to conceal whatever evidence that could be brought forward in the case. That could be correct. But I tell you very, very true. I tell you very, very true that whenever you set fire deliberately with an intention to cause damage deliberately, we don't consider that an accident. We call it arson. You can see the name on the screen. We call it arson. You understand? And it's a it's a criminal act. We call it arson. Arson is fire set deliberately. So we cannot refer to it as an accident, something that you deliberately, it's not an accident. So we call such fire outbreak arson. Let's continue with what we're talking about, source of ignition. Where can ignition come from? Open flame, external spark, internal spark, hot surfaces. We are entering dry season. We're going to be seeing some static electricity, even now, even with our clothes. Especially sometimes when I'm making the bed, my bed sheet during the harmattan, when you lift it up, when you off the light in your room, and then you try to lift your bed sheet up, you see sparks. You understand? That's an example of static electricity at a lower level, Of course, it appears also even in higher level. You understand? All these are sources of ignition. Fire has different classes. We have class A fire, which is fire that usually involve materials like paper, like textile, like furniture, like wood, like plastic. You understand? And usually this kind of fire, if they happen, using any cooling agent like water will go a long way to help you deal with them. We have class B fire, that is fire involving liquid. You understand? Or liquefied solid like paint, like oil, like fat, and so on. We have class C fire, which is the one that involves gases. You understand? We have class D fire, fire that involves metals, and so on. So we have class F fire as well. That is the one that involves something like cooking oils and all that. What do you call it? There's a class of fire that stands on its own. That's electrical fire. It's difficult to put it under any class, whether class A, class B, class C, class D, or whatever. The reason is because it could start as electrical fire, but it may not continue as electrical fire. If the fire originated from electrical from electrical fault, it could engulf the cotton, it could engulf the wood, it could engulf the papers. So when it began as electrical fire, it may not be sustained or continue as electrical fire. So electrical fires are usually classified on their own. When fire is happening or when fire starts, how does it spread? It's spread by means of what we call either convection, by conduction, radiation, or direct burning. When we say conduction, it means, for example, when you put fire on and you put any metal, you understand, on that fire, you discover that over time, the other end of the metal you are holding will become hot because it is conducting the heat across the body of the metal. When fire is burning, fire spread by the heat being transferred across other regions through the materials that are connected to that fire. If it is wood, maybe one end of the wood that is connected with fire burning, the body of that wood will begin to heat up until it gets to the other end and it catches fire and it goes up. Fire spread also by radiation, that is transferring heat through what? Through air. It can also grow or spread by convection, you understand, which usually is a common transfer of heat through liquid. So convection, transfer of heat through liquid source, conduction, transfer of heat through solid materials, and then radiation, transfer of heat through air or through gas, and then it could be just direct burning. What causes fire? Combustible materials, flammable materials, electrical issues, hot work, machines and equipment can do that. When we put our scraps, our waste in anywhere, our dust, trash it anyhow. Careless smoking, people will finish probably smoking and they will just throw it away anyhow. That has caused a lot of wildfire here in Nigeria and outside Nigeria. So as an organization, we must consistently carry out what we call fire risk assessment, meaning finding out how vulnerable are we to fire outbreak. What's the level of risk to fire that we currently face? And how do you do that? Be intentional. Identify those things that could cause fire, what we call fire hazards. Are your activities depleting oxygen? Does your activity involve any form of flame and heat? Does what you do bring out smoke? Is there any gaseous combustion product in what you do? Are there possibility of structural failure of your building? There are many areas you can actually look into and ask yourself, does that expose us to any form of fire risk and so on? So fire hazards, how do you identify them? Identify anything that can burn, that is combustible. Identify any area in your organization that can be source of heat. Identify any unsafe act that can create fire outcome or in any fire accident, and any unsafe condition that can create fire accident. Usually when we identify the fire hazard, we also ask ourselves, who could be at risk? If it's an accommodation or building, the people who are sleeping there could be at risk. The persons who are physically or visually or mentally challenged could also be quite at risk in situation like that. People who are unable to react quickly, of course, maybe because of they are sick, maybe because they are disabled, they may not be able to respond quickly when there's a fire, are at risk. Maybe persons who are isolated, they are doing a lone walk, meaning they are walking far away from where other people do not really see them all the time. Those kind of people may be at risk. So when you identify fire hazard, find out those who could be at risk, and then you begin to reduce the risk. Remember, when it comes to reducing, minimizing, managing risk, you use hemp. Remember the hemp we talked about, and of course you record your findings, and you monitor from time to time to see whether the method you are using to minimize the fire hazard or the fire risk is still effective. One of the areas that the Federal Fire Service is doing well in Nigeria is they're mandating organizations to now have fire plan in their building. It's a good thing to do. An organization should have a fire plan, you understand? And the fire plan should indeed be kept where people should be able to see it. So when there's a fire outbreak, what do we do? So the fire plan must indicate escape route. It must tell us the number of exits that are available, the number of staircases, and so on, the fire resisting doors, the fire resisting walls. The fire plan must also make provision for fire signs, and then notices with pictures, just in case some people cannot read. It must tell us also the position where the fire warning call and sounder or rotary gong is located. You understand? Location of the emergency light, location of the and type of firefighting equipment like extinguishers must also be indicated in your fire plan. The whole essence of this discussion on fire is we need to make effort to prevent it. We shouldn't allow ourselves, our organization, to get to that point where we have to start fighting. But if it happens, let's fight the fire. You understand? Let's respond to the fire. But the major proactive thing to do when it comes to fire hazard is find a way to prevent it. If you're going to prevent fire, you got to find out everything that will cause fire in your workplace, what we call fire hazard. There need to be proper control of them. You need to also make sure that there's a control of any source of ignition. Sources of ignition should not be left open without responsibility. Somebody must be stationed and be responsible for any source that heat or ignition could come from, so that they can be controlled. We need to make provision, have the right kind of fire protection equipment as well. These days we have some highly precision and also highly sensitive fire protection equipment that are able to detect and even know when your temperature is going above a certain range, and it triggers maybe a warning. Sometimes also we even see water sprinklers, that once they detect any similitude of fire, they respond immediately. Those are quite good systems for prevention as well. You understand? Regular inspection and maintenance of our equipment will go a long way as a preventive method, and responsible persons or employees should be assigned to fuel sources. You understand? If there are sources of fuel in the organization, let it not just be liberalized. Anybody can just go there, do whatever you want. No, there must be responsibility. Somebody must be responsible for all fuel sources. So employees should make sure that, or you should make sure that sources of ignition does not come close to fuel. Don't keep any source of ignition near to fuel. Sometimes some of us, we where we keep our generator is also where we keep the reserve fuel. It's actually not a proper thing to do. Please, is because that will mean keeping the fuel and source of ignition together. Some of us even go to extent that our gas cylinder, cooking gas cylinder, is right where the burner is. That is also quite a risky action, to unsafe act to carry out. I know somebody asked me, Amadi, but some people use camp gas. What about that? The camp gas is attached, the burner of a camp gas is attached to the cylinder. You understand? What about that? And I tell the person that using a camp gas inside the house, inside your kitchen, is an unsafe act. The name is called camp gas. It is designed to be used in an open atmosphere. It is not designed to be used an enclosed space like your kitchen. Why? Because if there's an explosion, because the kitchen is enclosed, so to speak, the impact of that explosion is going to be high. But if the camp gas was used for what it's intended for, that is for open atmosphere, when there's an explosion, you have enough airspace to dampen the force, the impact of that explosion. So when we see people, or maybe yourself, using camp gas in your kitchen, it's quite an unsafe act. It is, because you are increasing the likelihood of the impact in case anything like explosion happen. I know we used to say, God forbid. Indeed, God forbid. But let us walk with wisdom that God also have provided us. You understand? So sources of ignition should not be near to any fuel source, or in an atmosphere that may be flammable. Is important. Fuel leaks should not be allowed to fall on hot surfaces. Some of us that drive, sometimes you go to the mechanic, they clean your fuel tank and they didn't cover it well. And then you go to filling station and you fill the tank, you see it leaking from under. Do not allow that to drop on the exhaust when the exhaust is hot. It can be quite devastating. It can be source of fire outbreak. You understand? So provide containment devices to hold fuel leakages, yes, in anything. No smoking sign should be displayed and enforced in areas where you know fire can easily take place. Anybody who is working with handheld, who is working or using flammable material should be aware what the hazard of that material is. If you are working with gas, be aware. Work permit should be obtained before any kind of hot job is done, like welding is hot job. We can go on and on and on and on. Let's talk about fire extinguishing. We just finished talking about prevention. Let's talk about extinguishing fire, and I think I will end the subject today here so that we can all go and rest. How do we fight fire in case it has already happened? Remember, I said the ultimate is prevent it. But what in a situation whereby the fire, we could not, and it has happened? What should be the response? How do we approach the fire situation? In extinguishing fire, we also take advantage of the fire triangle. We say that in the fire triangle, if you don't mind, let me display it again. Where is that, my fire triangle? Okay, this is it. We said in the fire triangle that these three elements need to be available before fire can occur. If you make that statement in another way, it means if any one of these elements is taken away, even if fire was happening and you take oxygen away, that fire will die. If fire is ongoing and you take fuel away, you starve that fire of fuel, that fire will die. If fire is taking place and you cut off heat, that fire will die. Because the three must, emphasis on the word must be available before fire can be sustained. That's the same principle we apply when it comes to fighting fire, extinguishing fire. The method we use in extinguishing fire is also three: starvation, cooling, and smoothing. What is starvation? Starvation means removal of fuel. When fire is happening and you cut off fuel, you have starved that fire of fuel. The common thing we do at home in the kitchen. Sorry, my modem, I didn't know I was not charging it, but it's working now. It's fine. Sorry for that. So I'll just continue so that I can wrap up. My plan was to close at 8:30. So I think I'll have to still work towards that. I assure me presentation. You understand? So one way we fight fire is actually to starve it of fuel. We call it starvation. Another strategy for fighting fire is what we call cooling. Cooling means, yes, cooling is about taking away heat. So cooling is a strategy of cutting off heat when fire, and that's why some people use water to fight some fire. I use the word some because not all fire. You can't use water to fight electrical fire. You'll be creating more hazard because water is a good conductor of electricity. But cooling is a strategy to eliminate heat when fire is ongoing. And when you achieve that, the fire will die. Smothering is a strategy to cut off oxygen. I'm sure some of us must have heard, maybe in an event of fire, somebody shouting, bring sand, bring sand, bring sand. And they say, pour sand. Sand is a smothering agent. Sand will cut off oxygen. Maybe you've heard people shouting, put Omo in water, put Omo in water. What do you think that will happen? Omo is going to produce foam in water. That water will provide cooling. The foam will cut off oxygen. Without foam, oxygen won't have access. Some of us at home, you are cooking. Maybe you are bleaching your red oil. For many reasons, maybe it was late in the night. You didn't know that your groundnut oil was exhausted, and you say, let me convert my red oil to our groundnut oil. And then you started bleaching it, and probably became so light, and your pot get engulfed in fire. What do? What you should never do is never pour water. If you pour water, that fire will rage. What do? We find the cover of the pot and cover it even when the fire is still inside the pot. And once you cover it, next a little while, when you open it, the fire will go. That cover you did is a smothering agent. You try to cut off oxygen. Sometimes we can even use the kitchen towel, damp it in water, and then squeeze it a little and use it to cover. Because it is still very wet, it will cut off oxygen, and the fire will not yet burn that very fabric. So fighting fire, it is still by trying to find a way to eliminate any of the three elements of fire. And it will go a long way to help out. On our platform, I'm going to share also a brief video on how we use fire extinguishers, because fire extinguishers also are used for fighting fire. Even before you see the video, it's important to let you know that there are three major types of fire extinguishers depending on what they contain. Some of them contain water, pressurized water, and that's what we call pressurized water extinguisher. Some of them contain carbon dioxide. You understand? That's what we call the one containing gas. You understand? That's the gas there is carbon dioxide. Some of them contain dry chemical powder, what we call DCP. You understand? I can tell you a lot of extinguishers you have outside there contain DCP, dry chemical powder. In the past, we used to have color code for these cylinders. When you see a cylinder that is black in color, you will just know from afar that now CO2 now in the inside, as in carbon dioxide. You understand? When you see the cylinder that is looking more like blue, sky blue, you know it's pressurized water that is inside. These days, most cylinders come in red, so you need to indeed look at the label properly before you can know what the content is. Is that okay? It is past 8:30. I would like to end the meeting here. Thank you, guys. I'm going to share a brief video because to be better illustrated with that video, I'm also going to share a video on one of the topics that time didn't allow me to treat. That is first aid. Please, I need us, the facilitator must not do everything. Please, I need us to also, even before your assessment, take your learning on basic safety, basic security, and also on what the accident investigation. Those two are very, very important, I beg you, and on safe act auditing. So please, to allow us to go and rest for the day and get ready for tomorrow by God's grace. I will stop the meeting here. Any question, please? You're free to on your mic. Many of us, Jonathan, you really disturb us today. Son of Grace, that was unlike you. I don't know whether you were not aware of that. Your mic, I put you in the waiting room like twice. Victoria, you also disturbed us so much today. Please, let's take note of that. Whenever we are in meeting like this, it's extremely important that we obey the rule of the virtual meeting. Thank you, everyone. God will be with you and bless all of you. If you're running HRM, remember to join your HRM class. You can decide to be physical at our training facility. You can decide to join the class virtually. Thank you. Look out on your platform to know the timing for your class. Have a wonderful night and stay well. Thank you.